Hi guys, Alistair Brunton here, founder of oslo.vision. Today I'm going to walk you through using the tool to create a data set, annotate it, and train a UL v11 architecture object detection model. So let's get started. So, yep, open a browser, heading over to oslo.vision, and then you get to the front page of the app here. You can see we've got my dataset management tools. You can do a collaborative labeling workflow. We have API integration for active learning based workflows. We do not provide any training stuff, so you can link in your own training stuff. So you can either train on your own hardware or you can use Google Colab, which we'll be using in this video. You can see we have three plans at the moment, free, pro, and enterprise. Free's enough to get started, 500 images, 2 users, 1 project. So yeah, you can sign up for that. No credit card or address details needed. You can just sign up straight away. So yeah, you can hit on the sign up for free button. It takes you to this page. You can use your Google login. We're using a test account here on the name of Dave Wilson. Yep, there we go. It will generate a organization name for you to give your workspace a name. But in this case, we will just give our own name, Super Cool Company. Let's go. Next, we need to create a project. We will call it motorcycles and bikes. I have a nice data set, including motorcycles and bikes, which we will annotate and then use that to train a model. So we get a project. Yep. So we've created successfully. Now we need to add images and annotations. You can actually upload data sets from other services if you like. In this case, we just have a directory full of images, which we will annotate. So yeah, this annotates, and then, well, it's not annotating, sorry, this is uploading to Oslo. See the status bar there, up it goes. There we go. Now we're just processing those images. It shouldn't take too long. Should be around about 150 images. There we go. So we have an annotation job which we've created. They all sit in the unannotated step. So this allows you to go through the images and annotate them one by one. This is our annotation editor. So have a look at some of the images. And you can see in this case we are using 640 by 640 images already. Number of different bikes. So yeah, we can use our tool to annotate them in this example with bounding boxes. So there's the bounding box tool on the top right, which you can select. And then there's also a move tool. You can zoom in, zoom out. So yeah, you just go to top left and then you can select what you want to annotate. There we go. And let's get a class of bike. I mean, I think bicycle would be the correct term, but for this example, we're going to use bike as our class name. Yep. So we can go through the images one by one and annotate them. I don't think we'll go through all 153 images now. You guys don't have to sit and watch that, but you get the idea. There is some keyboard shortcuts that you can use when you're for the power users out there, where you can go back to the previous image, the next image. You can leave the annotator, delete images, and there's also delete annotation functionality as well. If you're wanting to edit existing data sets that you've imported. So there's this move tool where you can move and resize annotations, which can be useful when you're fine tuning. So yeah, here I have a kid's bike. There we go. Another bike. There's also train tester validation splits that you can set on the top right there. But when you're exporting the images, you can define the split there. if you like, to rebalance the dataset. In this case, we have a bit of a complicated example. There's a lot of bikes there, so it's a bit of work, and there's been going to be a lot of overlapping bounding boxes. If you're dealing with this type of data, it may be better to go for a segmentation approach with bike segments in the training data as opposed to bounding boxes, because there is a lot of overlaps. But generally, our data set does have a lot of standard bikes, so it's not a problem. And boom, I've just fast forwarded and we have a data set which is fully annotated. You can see both motorcycles and bikes have been annotated in this data set. We have 153 images. You can also zoom in and zoom out. Like we could have chosen to annotate the bike in the background there in the top left, but have opted not to do so. So yeah, so the next step, I think we want to create an export of this that we can use for training. Whoops, no images in the dataset. Please add to dataset. So yeah, you have to click on the plus there to move from annotated to in dataset. This is to allow for if you've got multiple annotators in different states of annotation. You have to physically add them to the dataset when you want to do so. So here we see we've got 153 images in the dataset. We're going to have a look at them. They have the images, and it shows you the current split that they have, test, train, or validation. And yeah, we can click on export images. So create a new export, and in this case, I think we're going to use YOLO as the export type. This is the format for the annotations in the zip file which will be generated. I think we'll adjust the split slightly for a slightly larger number of validation images. I personally prefer a slightly larger validation set to make sure there's a good class split there. So yeah, now it's churning away, creating an export. Again, not so many images in this data set, so it should be relatively quick to do so. There we go. Okay, so we've got a dataset which we could download and have a look at. It's version number 1. To train a model, we're going to use Colab in this case, so I think we should try training a YOLO V11 object detection model. So you can just click on the Open in Colab button there. Here we have example 1, which you can modify. Again, you can use this Python notebook on your own local machine if you like. There's nothing Colab specific in the code here. So if you have your own machine or another service that you'd like to use for training, you can do that. So yeah, the first thing to do is to make sure that you connect to a hosted runtime with GPU. Because by default nowadays you are connected to a CPU instance, as you see there. So we're going to select T4 GPU. Yep, now it's connecting to that. It takes a few seconds to connect. There we go. So we can just test that by running the NVIDIA SMI command to confirm that there's a GPU attached. And run anyway. There we go. Yeah, it is T4 by looks of things. Yep. Let's install Ultralytics. That's what we're going to use for training our YOLO V11 model. Good stuff. Let's create and set a home directory. Now let's set up pulling our export from Oslo via our API. You need 3 things. Let's go for your project identifier to begin with that you can paste in here. You also need an access token, which is an API access token. So we will generate an API access token. This is a secret token that you should not share with anyone apart from your teammates. So we can go to settings and then API and then create API token. Okay, we've created one. That's the API token there. You can only view that once. Okay, pasting that in there. It is dataset version 1 because we've only exported one dataset. So, yep, let's install the oslo.vision pip package and pull down our dataset export. I'll just double check that we've only got one export version. Where are we? Yeah, there we go. One export version. So, okay, let's run this. There we go. Let's check that we have an unzipped. There we go. Same content, more seconds and bytes, YOLO 1. So we've assigned our dataset path, so we can pass that into the CLI for training a model. So let's just train for 100 epochs. We defined image size as 640, which is true. And I'm going to train just a nano model architecture. That's very fast to train for the purposes of this video. If you want higher accuracy, you can use a larger model architecture. Okay, I'm just going to speed up this a little bit. You don't have to sit and watch 100 epochs of training. That is some fast training. Boom. Now our dataset is relatively small, so those precision and recall values do look too good to be true, but based on the dataset, they are extremely good. So we have a look at the training results. It's always important to validate your training before putting anything to production. It's good to sort of understand the results that you're seeing. So when you train with the Ultralytics tool, there's a number of different outputs. The confusion matrix is the place where I generally always start. You can see here we've only got two classes, and yeah, we've done very well with the motorcycle class. We're 100% being correctly identified. Bikes look to be not quite as good, where we've got 6 examples of background images on bikes and one where it's actually we're predicting a background as a bike. Here we have some training results showing some graphs. Looks relatively good. We can look at some validation batch predictions from the validation set to see how it's actually performing, and you can see here it looks to be doing very, very well. So after you've looked at this, one of the good things to look at is the test set. So this is something that the model has not seen during the training phase. So we can test the model looking at images that it's never seen before to see see how it looks. This here is just a step to do what the graph that you see, not the graph, but the table that you see at the end of the training process again, where we can run on the validation set again to have a look at those precision recall values. They're always nice to compare between different trainings to see how your training is progressing when you make changes to your data set. But the test set in some cases is actually great to keep static between trainings, or have your own test set which is out with the data set altogether, or in its own project, to really be able to compare models between trainings, because you want to really see if your model is getting better, or in some cases, unfortunately, worse. Whoops, got an error here. Why is that? Looks like we've potentially got a problem with this dataset location variable. I think we should be using a different one. What is that? I think it's dataset path potentially. Yeah, there we go. Dataset path. Let's change the code to refer to dataset path. There we go. Copy that. Missed an H. Okay. Let's try that. There we go. We've gone through 20 images. Let's have a look at the results. This code here will take a random collection of 10 of them, which can be useful if you've got a larger training set. But really, we could change that value to 20 to just view all of the images. Look at that. See how we've got on here. Definitely a motorcycle. Definitely a bike. Should be more images. Where are they? I can scroll up here. There we go. Motorcycle, motorcycle. Uh-oh. That doesn't look right. There's one issue here. It's a missed bike there, and this is definitely not a bike. So you would see that we should really be looking for similar images and tagging them accordingly as motorcycles, and seeing if we can fix that edge case. So yeah, have a look again. Generally looking pretty good. Same image we've seen already. That's all looking tip top. So yeah, now you would probably increase the size of your data set potentially. Check the test set again, see if you can improve the performance. I mean, it is already pretty good. And yeah, the next would be yeah, working out where you're going to go, where you're going to go from there. You're going to, if you want to say deploy your model to production, you can just write your own simple inference server, which we have detailed in another blog post of how to do. You can see there's a data set in there. It's downloaded on the machine on Colab, but you can also download the weights. So what you'd want to do is go to runs detect. You can see train, and then weights and best is generally what you want to go for. So you can download those file there, and then that's your model weights that you could then use to implement a object detector for detecting bikes or motorbikes. What would also be interesting would be adding data of non-bikes and non-motorbikes to see how it performs. Like what happens if it sees an elephant, for example. What happens if it sees a car? Does it correctly perform? So I mean, you could really flesh this out more and more and more. But I think this has given you guys a good example of what's involved in starting from just a collection of images and training an object detection model using oslo.vision. Again, the 500 image limit is enough to get started and train reasonably quality models, but if you want to scale up from there, I definitely recommend getting one of the paid plans. So yeah, thank you very much for your time, and goodbye.